Flack math! Give me some math and I'll give you some flack. Flack math!
Symbols of inclusion. All right, so fraction bar, when you see a fraction bar, it's like a big parenthesis. So let me just show you a couple examples. It's kind of like this: 5 times 4, parenthesis, divided by 2 times 4 plus 2 in another parenthesis. Another way to write this symbol, these symbols of inclusion, is like this: 5 times 4 over 2 times 4 plus 2. So you're still doing this first and this first separately, and then you're doing that last. So whenever you see something like this is technically called a symbol of inclusion. It's kind of like a weird looking parenthesis. Okay, but when you see this, think of it as parentheses around this, parentheses around this. So you do the top and the bottom separately first, and then the last thing you do is divide. Okay, but this is a natural thing for most people, so it shouldn't be too confusing. Let's just try 2 examples, and then we'll do lesson 94. Example 1. 4 minus parenthesis 3 minus 7 plus 3 times 2 plus 6 all over 2 times negative 4 minus 1. Let's see if you can do that. You can try it in your head if you want. You should get a nice little negative number.
Is it negative 2?
Wow, nice work. It is negative 2. Let's see what she did. First things first, there are parentheses inside of parentheses. Remember, the top and the bottom are one big parenthesis, right? But you can do this first. So that's negative 4, right? And you can do this, which if I chicken scratch, that's negative 5, right? Well, this is being multiplied by 2. And this is being subtracted. So minus negative 4. So minus negative 4, what does that mean?
Plus.
Yeah, so plus positive 4. And then we're going to do this next, right? We're going to do the 3 times 2 next, and then this. So then we get, let's see, 4 plus 4 plus 6 plus 6 all over negative 10. Right? What's 4 plus 6 plus 4 plus 6?
20.
20 divided by negative 10 is negative 2. Okay? You try one, all right?
I need my paper.
Okay, this time you're going to end up with a fraction, but that's okay.
That's just complication of life.
Try that one.
By the time I write it out, my channel will be done.
You doing it in your head, Austin? This one, don't be confused by this little thing here.
Is it? Should I use it?
Yeah, you got it? Nope.
Whoa.
Or what do you got? Nope. How'd you get 13 down here? Yes.
Let's go.
Okay. All right, let's see what you did. What'd you do first?
I pulled out my calculator
Okay.
and I put everything in the calculator just like on the board.
So did you use parentheses and everything?
Yeah.
So did you put one big parenthesis around that first? And then you divided by that?
No, I just got the answer.
Oh, you got the top separately and then you got the bottom separately and then you divided?
Yeah.
Okay. And that's the same thing as parentheses. You could do it in parentheses, but in your calculator, instead of starting with the 6, you would start with the parentheses.
Yeah.
6, blah, 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 and then another parenthesis, divided by, and then another parenthesis, because remember, you got to write it like this. So you could do that in your calculator like that. But if you don't, you're going to get it wrong. So that's why calculators are tough if you do a problem like this. But you can still use your calculator to do the individual problems within this problem. Okay? What's negative 4 plus 3?
-1.
Right, so this is 6 times negative 1, right? What's negative 2 minus 6?
4.
No,
-1.
no. Negative 2 minus 6. How do you feel about subtraction?
-8.
So plus negative 6, negative 2 plus negative 6 is negative 8. So this is minus negative 8. And then what is, and then we're just multiplying by 2, right? So that's two multiplication problems that we have to do on the next step. All right, and then I'm going to do this. What's 2 minus 4?
-2.
Yep. So there's a multiplication problem down there. All right. So let's do that. So then what's 6 times negative 1?
-6.
Negative 6 minus what's negative 8 times 2?
-16.
Negative 16. So what's negative 6 minus negative 16?
What? Negative? That would be positive.
Yeah. So you go bach. So you have negative 6 combined with the positive 16. And that gives you 10 over negative 6. And you can reduce that to negative 5/3 because a positive divided by a negative is negative. So you can put the negative out front or on top. You can have it on the bottom, but it just looks better grammatically to either have it out front or on top.
Was that a free problem set?
No. All right. Does that make sense, guys?
Yeah,
So just go slow. Don't try to do it in your head. And you'll get it. So let's do lesson 94.
Oh. No free problem set, Mr. Flack?
I'll give you, at the end of this lesson, I'll give you a free problem set problem, okay?
Okay. You know what?
All right, we are going to add like terms.
Casper should not be sitting in.
So remember,
So I almost.
when you add and subtract in math, you have to be picky. Remember adding fractions? What do you need to add fractions?
You have
Common
to find-
denominator.
Yeah, so you can only add the same kind of fractions. Well, that's true for any kind of math. You can only add the same kind of money. You can only add quarters with other quarters. You can't say 3 quarters and a nickel is 4 quarter nickels. You know, you have to get the same kind of stuff first before you can add them. Okay? So adding like terms have to have the same variable in it, and they have to have the same exponent of the variable. So x squareds cannot be added with x's, but x's can be added with x's, okay? So we talked about terms a little bit. Terms are separated by addition and subtraction symbols. Okay, so terms are added or subtracted. addition or subtraction. Okay, so for example, how many terms am I going to put on the board here? How many terms is that?
5? Or wait, no.
4. Well, no. Those are like terms, so terms.
Well, don't worry about like terms.
Yeah, so 6.
There's 6. Do you see the 6?
Yep.
Because there's 5 addition or subtraction signs, which means there's 6 terms. Because, there's one on the beginning and one in the end. So here's one, here's one, here's one, here's one, here's one, and here's one. Okay? Now, technically, this is not a 2. What is that? A -2. So it's easier, I think, to chicken scratch before you start combining like terms, chicken scratch. Okay? So if I wanted to combine these terms, I could. So see how this x could combine with this 3x. What does that make?
Just makes 3.
Well, how many x's is this?
That's 1. So
Yeah,
4x.
if you don't see a coefficient, a number in front of it, there's a 1 there.
4x.
So this is 4x. What about this? I can combine these two together. What does that combine to? Be careful.
Negative 5y.
-5. Good job, guys. Because this is not a 7y. This is a -7y. So -5y, I could just say plus negative or minus 5y there, right? Okay, and then what else do we got? Oh, we got constants here. What is that? Just a 3, right? Okay, so you're never, like over here, how this was 5 minus, you follow that. You follow whatever's in front of it. So this is a +5 combined with a -2. It's a +3. All right, so with that, let us try something else. I'm going to give you one example, and then I'm going to do a free problem set, okay? So I want you to combine these like terms. Combine any like terms you see. So this is practice. I want to simplify. That's one of the biggest rules of simplifying. If you go into Starbucks and say, I want -3 Frappuccinos, 2 Americanos, 2 Frappuccinos, 3 waters, and 7 waters. They're going to say, go figure your crap out and come back when you're ready to order. Okay? Professor X.
Have you ever tried it, Miss Flack?
Alright, I got it.
In the Starbucks?
Yeah.
Doesn't it?
Professor X is
I
one
should have.
you know.
I got them.
Well, that's at least what they're thinking in their head, right? What'd you get?
I got -1x
Uh-huh.
plus
Yep.
what do I have? Plus 2y
Uh-huh.
plus 10.
Yeah, so this guy didn't have anybody to combine with.
Talking to me?
So these x's can combine, these constants can combine, but if you want to go through and kind of mark out similar terms, you can. What I would not recommend is putting boxes around some and triangles around and circles around, because look what happens if you try to put a box around something like this. What does that look like? It looks like a +3x. So I wouldn't recommend doing that. If you're going to do something, do underlines. So maybe you're underlining the x's with one line and the y's with the 2 lines. It doesn't matter. Just be consistent. Or you could do something like this as well. So what does this combine to? -3 fighting against +2, -1, or you can just say -x, right? That's still a -1x. Okay, and then your y's, no other y's combined, so you just have that 2y. And then the 3 and the 7 combined to a +10. That's not bad, right? So this is what you're going to be doing a lot of in algebra next year. Combining like terms. That's one of the first, when we talk about simplifying, we want to get rid of parentheses, and we also want to combine like terms. Okay? All right. Example 2. And this is one for a free problem set. Ready?
Stupid.
Yes.
3x plus 2m
Hello.
14x plus 2x
It says Z.
minus 4m plus 4 minus 2.
What the?
What? So when you have something, show me. Three x plus 2m minus 14x plus
Hello.
minus 4m plus 4 minus 2.
Hello.
Hello.
Xavier, shut.
We're combining like terms.
Hello.
Did you just say no?
Can you hear me all right?
Yeah, we can hear you. Can you
Sweet.
hear me?
Mr. Flack.
Little buggy, but okay.
Little what? Did you
Little
call?
buggy.
I'm working on it. Jeez.
Mr. Flack.
Yeah.
Is it 13x plus
I don't have no Chick-fil-A today.
God.
good. What is that?
Screw you, Henry.
Plus 2.
It's hard to do in your head. I mean, just like any math, it's hard to do in your head. But
Unless it's adding.
well, we are adding.
That's pretty hard to add in your head.
Austinian. Greetings.
Okay.
And
John.
mute.
I have an answer.
All right, buddy. Let's see what you got.
11x plus negative 2m plus 6 minus 2.
Okay. Well, you can, that's not right, but you can also combine those.
I need to stop taking time. I need to get this whole
24.8 repeating.
I thought you read it.
I just did. But the thing is, he can unmute at any time. So hopefully he takes the hint.
Alright, I got an answer.
All right, I'm coming to you, so I can just look at it. Nice. Good job. All right, so look at these M's. You guys said 2M. Where? Look at the X's. So you forgot about this X. Whoever said 11 or negative 11 forgot about this X.
Looks like a lamb.
There's 3 different X's, right? Okay, what does that all that combine to?
Negative 9.
Well, I know you know.
Okay.
How is
Okay.
that negative 9?
Because look, this is a negative 14
Oh,
and then a positive 5.
I thought that was minus 14.
It is minus 14. But that minus 14 is the same thing as a plus negative 14. Okay? So if you need to chicken scratch and make it easier, then do it. So I'm going to chicken scratch over here too and over here, even though 4 minus 2 I think I could probably handle. But 4 plus negative 2, not any more difficult. So now combine those and you get a negative 9x. All right, now let's do the M's. What are the M's combined to? Here's a 2M and a negative 4M. And I think you said positive 2, Austin, but what did you say for
Yeah, I
M's? Did you?
said positive 2.
So that's a negative 2M. So I could leave it minus 2M because that's still you're left with negative 2M, right? Or you could say plus negative 2M. All right, and then the constants, you just have a 2 there. 4 and negative 2, those are right next to each other. It's nice, easy. 4 and negative 2 gives you a 2. Okay? Yes, Emerson. Yes. Can.
I bet.
Does that make sense, guys? All right, so take your time, take it slow. Xavier, good to see you.